video. So in that video, we talked about water bottles and hybrid engines. So I'll just go over them briefly here. So in the water bottle on the right, that's a 12 fluid ounce bottle of water, which is about 355 milliliters. Now it says that on the label. That's an assumption on the label that we are given. So we assume that inside the bottle, there is actually 355 milliliters, what it says on the label. So for the customer, what are we asking? We're asking, well, is there on average at least 355 milliliters of water in each bottle? So why do we say at least? Well, that's because if there's 355, that's what we're paying for. But if there happens to be 360, well, that's fine because we're getting a little bit more than we're paying for. So we can put that in a mathematical expression of quantity of water is greater than or equal to 355 milliliters. Now, what if we're the manufacturer? We might ask a different question. Is there, on average, exactly 355 milliliters of water in each bottle? So we can write that as an expression, quantity of water equals 355 milliliters. Why is it different? Well, if we're the manufacturer, if we underfill the bottles, we're cheating our customers. And they may be very angry with us, and the government may be angry with us, and things like that. If we overfill them, we're cheating ourselves because we're making a higher operating cost for ourselves. So instead of putting that extra water into future bottles, we are overfilling current bottles. So if we're the manufacturer, we don't want to be under 355 or over 355. If we're the customer, we want it to be at least 355, either equal to or more than, because in that letter case, we'll get a little bit more than we're paying for. So it's all about how we formulate the question and our own point of view. So the second example we talked about was the hybrid car engine. So the company is claiming that this new engine has greater fuel economy. It's more fuel efficient. So the current engine in production is 30 miles per gallon. So they are claiming that this new engine gets more than that. So the manufacturer is making a claim it wishes to test. It is not testing an already existing assumption. It's not testing the status quo that already exists. It's testing something that it does not know if it's going to be the case or not. So think of the difference. The assumption on the water bottle was because it was actually on the bottle. This is sort of a claim in the engine case about some unknown. We know that the current engine that's in production is 30 miles per gallon. We want to test whether or not the new one gets more than that. And we do not know. It's a complete unknown. So that's the difference between an assumption and some claim about an unknown. And that's important when it comes to hypothesis testing. So thinking about hypothesis. When trying to formulate a statistical hypothesis, I want you to ask yourself the following question. Am I testing an assumption or the status quo that already exists? So in that case, the water bottle was that example. Or am I testing a claim or an assertion beyond what I already know or can know? And that would be the hybrid engine example. So they're making some claim about an unknown that they want to test, and that's whether or not the engine gets greater than 30 miles per gallon. Now, what if we turn this a little bit different way? If we wanted to test the gas mileage listed on a current car sticker in the window, we would be testing an assumption then, not some claim about an unknown. So if I go to a car dealership, I look on the sticker of the car, and it says this car gets 26 miles per gallon on the highway. Well, that is an assumption that's a given to us that we can then go test. That's our null hypothesis in this case. Now, in the engine we were using before, we don't know. We were just testing whether or not it's greater than 30 miles per gallon. Two different things. So think about that in your mind. Am I testing an assumption, the status quo that already exists, or am I testing an unknown claim or assertion that's sort of beyond what I can know? So why is this concept so frustrating? Well, one thing is that it runs counter to how we think about things in our everyday life. But again, as I said at the beginning of the video, we set up and test null hypotheses hundreds, if not thousands of times a day, unknowingly, in our daily lives. So formulating hypothesis can be very frustrating. A real PITA, or a pain in the you-know-what, to be honest. Now, the reason that's the case is that the null and alternative are two opposing roads that lead to the same place. So it's two opposite directions that come to the same place, which is this overall hypothesis formulation. Now, by definition, the null and the alternative hypotheses are opposites. They are mutually exclusive. So the null and the alternative cover all possibilities, but never the same possibility. And you'll see what I mean by that here in a minute or two. Now, the null is either rejected or it's not. Only if the null is rejected can we proceed to the alternative. And that goes to the point we'll talk about here in a second, that everything is centered on the null hypothesis. We either reject it or we don't reject it. Then we proceed on to the alternative if we do reject it. Now, researchers can start with either the null or the alternative, and then form the other as a complement to the first. Now, which to start with largely depends on the point of view of the researcher or the analyst, the context of the problem, and what can or cannot be assumed to be known up front. So again, think of the water bottle and think of the hybrid engine. With the water bottle, we knew the volume from the label, so we could test that. That was our assumption. For the hybrid engine, we were just trying to test whether or not it got greater fuel economy than our current model. See, there's no assumption there. There's no assumption there whatsoever. It's a different way of approaching a problem. And in that case, that would have been our alternative. So again, we haven't really defined what the null and alternative are formally, which we'll do here in a few minutes, but I just want to set the stage sort of for what's coming up. Now, you can think of the null and alternative as sort of a soup or a word salad. So when we think of the null, we're thinking of things that we can assume, things that are given to us, or some status quo that already exists, like the water bottle label. So we accept whatever the null says as true, and then we can test it. And then we can either reject that null or fail to reject that null. Now, the alternative is almost always something we do not know. It's some unknown, we're making some unknown claim or unknown assertion or something we're testing. So think of the hybrid engine. So this is something that might be true. Let's test it. If not, the truth is something else. So again, the null is about an assumption that we can either reject or fail to reject. The alternative is like some conjecture. It's some unknown assertion that we're going to test. Two very different things. Now, how about the null and alternative symbols? So for the null hypothesis, it's just H sub 0. The alternative is H sub A for alternative. Now, what we mean by null in the null case, null means nothing new, nothing different, nothing new to see here. The assumption or the status quo is maintained. So in our water bottle example, if we take 50 bottles and we measure the amount of water in each one, and let's say it comes out to 355.4 milliliters. Now, our null hypothesis was that it equaled 355. So is 355.4 enough to reject that null hypothesis? Probably not. So when we say null, we means that, well, there's nothing new. That's what we expected. Our assumption holds up, and things like that. Now, the alternative is simply the other option. So when the null is rejected, and that's all it is. It's nothing more than that. So if we reject the null, then we move to the alternative, and it's simply the other option. And again, we'll talk about how to formulate these here in a second. Now, a few helpful properties to understand how the null and alternative relate to each other. So we have the column on the left, which is the null, and the column on the right, which is the alternative. So for the null, we have an assumption of the status quo, nothing really new, and sort of the opposite of that is the rejection of that assumption, the rejection of that status quo. The null can be assumed to be true, or it's a given. So we assume that the water bottle is correct. We assume that the miles per gallon on a car sticker is true. And then the alternative is the rejection of that assumption, or the rejection of that given. Now you can think of this another way too. Let's start with the alternative. The alternative can be a research question that we want to, quote, prove. And I put that word in quotes because I'll tell you about that in a few minutes. I don't like the word prove in a statistical sense. But if you think of the hybrid engine, the manufacturer was trying to prove that the new engine achieved greater than 30 miles per gallon. So the alternative is about proving some conjecture. Now the fourth property is one that's extremely helpful when setting up these hypotheses in your work or in your analysis or whatever else it might be. The null hypothesis always contains an equality. So it always has an equal sign, or the less than or equal to sign, or the greater than or equal to sign. Either way, it always contains the equality part. The alternative does not contain an equality. So not equal to, or just less than, or just greater than some value. So when you're setting up your null and your alternative, and if you can remember this very simple rule, it makes it a whole lot easier. Trust me. So, using this last very helpful property, we can logically derive the possible null and alternative pairs. So we could have this, where the null is equal to some value, and therefore the alternative is not equal to that value. We could have this case, where the null is less than or equal to some value, therefore the alternative has to be greater than that value. And finally, the null can be greater than or equal to some value, therefore the alternative has to be less than that value. So notice that the equality sign is always in the null, and then the opposite of that is in the alternative. So when you're pulling information out of problems and you set them up, this can be an extremely helpful rule of thumb to remember. Okay, and this is arguably the most important slide in the first half of this video, because it's about how we set up and interpret our null and alternative statements. Now, first and foremost, always remember that all statistical conclusions are made in reference to the null hypothesis. As researchers, we either reject the null hypothesis or fail to reject the null hypothesis. We do not accept the null. So think of the null hypothesis as something we set it up and the data either knocks it down or fails to knock it down. So we either reject the null or fail to reject the null. There is no accepting the null. Now this is due to the fact that the null hypothesis is assumed to be true from the start. Again, it's an assumption. So we're either rejecting or failing to reject that assumption we already made. Now, if we do reject the null hypothesis, then we conclude the data supports the alternative hypothesis. However, if we fail to reject the null hypothesis, it does not mean we have proven the null hypothesis is true. So again, the ideas of truth and proving and things like that, I'll talk about here in a bit. I don't like those words very much. So think of like support, fail to support, and things like that. So if we reject the null hypothesis, we conclude the data supports the alternative. If we fail to reject the null hypothesis, it does not necessarily mean we have proven the null hypothesis is true. So think about this in terms of the water bottle. So we set up a null hypothesis that says the water in the bottle is 355 milliliters. So we go out and collect 50 bottles, and we take the mean of that 50 bottle sample, and let's say the sample mean of that is 355.4 milliliters. Now our null says it was 355 milliliters. Do we think that 355.4 is high enough to reject that assumption of 355? Well, I would say no. So in that case, we would say we fail to reject the null hypothesis of 355 milliliters. That's another way of saying our assumption held up. What we were given held true. Sort of our status quo is upheld. We could not reject it. We failed to reject it. Now, if it comes back that the bottle is 340 milliliters, that's pretty low. So will we say that 340 is the same as 355? Well, I would guess probably not. So what would happen in that case? Well, in that case, we would probably reject the null hypothesis. We would go on to the alternative that says the average is not 355 milliliters. So again, we're going to walk through that example here in a second, actually in the next slide. But I just want to give you an example of how we set up the null to either be rejected or fail to be rejected. And only if we reject it do we then proceed on to the alternative. And of course, this is because the null was assumed to be true from the outset. Now, failure to reject the null does not equate to proof about its truth. We're only setting up an assumption. We're only setting up an assumption to either reject or fail to reject. And that's all. That's all the null hypothesis is. An assumption to either be rejected or we fail to reject.